All right, let's dive into a topic that I think we can all agree has caused a lot of headaches for a lot of people over the years, subnetting. But we're going to do this differently. Forget the complex math, forget all the binary charts. We're going to look at the physical truth of what's actually happening on the network. If you've ever just stared at a subnetting problem and felt your brain turn to mush, you are definitely not alone. The reason it feels so impossible is that most explanations, they just jump straight into these abstract formulas. They treat it like it's a math test, and it never ever clicks. And this quote, this right here, gets to the absolute heart of it. Subnetting is not a math trick. It's just a decision. A simple decision made by software that tells physical, tangible hardware what to do next. And once you really get that, I promise, everything else just falls into place. So to understand that software decision, we have to kind of rewind. We got to forget about software completely for a minute. We need to go all the way back to the most basic physical thing in any network. We have to start with the wire. Think about it. A simple piece of copper wire doesn't know what an IP address is. It doesn't care about your email. Its only job is to carry these tiny little changes in voltage, a little pulse of electricity that stands for a 1, and no pulse stands for a 0. That's it. It's just a physical pipe for electricity. So here's the key idea I want you to hold on to. Think of this wire as a hallway. Every single device that's plugged into that wire is standing in the exact same hallway. It's a shared electrical space. This physical place is a local area network, or a LAN. It's not a concept, it's a real physical space. Okay, so if all of our computers and printers are just standing around in the same electrical hallway, how in the world do they tell each other apart? Well, that's where our first layer of identity comes into play. The solution's actually pretty straightforward. Every single network card that's ever been made has a unique MAC address burned right into its circuits at the factory. Think of it like a permanent, unchangeable name tag. So when one computer in the hallway wants to talk to another, it just shouts out its name, its MAC address, it's direct, it's local, and it works. Now, this whole system of just shouting down the hallway, it works great, in a small hallway. But what happens when you have hundreds or thousands of devices all shouting at once? Or what if you need to talk to someone who's not even in your hallway, someone in a completely different building? The whole system just breaks down. It doesn't scale. And this right here, this is the exact reason we need another layer of organization. This is where IP addresses finally enter the picture. Now this is so important to get. An IP address does not change the physical wire. It doesn't change the electricity. IP is a purely logical system. It's just a set of rules and labels that we put on top of the physical network. I like to think of it like a state line. The ground itself doesn't change when you cross from Colorado to Utah, but a line on a map creates a whole new set of rules and a new identity for that location. And this just illustrates the difference perfectly. Your MAC address is who you are. It's your permanent physical name. Your IP address is just where you are right now. It's your current house address. If you pick up your laptop and take it from your house to a coffee shop, your MAC address stays the same, but you get a brand new IP address from the coffee shop's Wi-Fi. Your name didn't change, but your location absolutely did. Okay, so with that foundation, the physical wire, the MAC address for identity, and the IP address for a location, we can finally define what a subnet actually is. And surprise, it has almost nothing to do with complicated binary math. But first, let's just get crystal clear on what a subnet is not. It doesn't physically do anything. It doesn't magically split the wire, it doesn't change the electricity running through it, and it does not alter the basic job of the local switch. It is a rule, not a physical change. So here it is, the big secret. A subnet mask is just a simple rule that your computer's operating system, Windows, macOS, Linux, uses to draw a line in the sand and define its local neighborhood. That's all it does. When your computer wants to send some data, it uses this rule to answer one and only one question. Is the IP address I'm trying to reach in my neighborhood, or is it somewhere else? Yes or no? So, how does that simple yes or no question actually translate into physical action on the network? Well, let's follow a packet and see exactly what happens. So, your operating system makes a choice. If the subnet rule says the destination is local, right here in my neighborhood, it just shouts down the hallway, using the destination's MAC address to talk directly to it. But if the rule says the destination is remote, it knows it can't just shout. It has to walk to the elevator. And what's the elevator?
It's the default gateway, the router, which knows how to get to other networks.
Let's just put it all together in order. Step 1. Your OS makes the decision, local or remote. Step 2. Your network card, the NIC, takes that data and turns it into electrical pulses on the wire. 3. If it's local, the switch sees the MAC address and delivers it right to the correct port. But if it's remote, Step 4, the router gets it, looks at the IP address, and forwards it on to a completely different network. A software decision leads to a very specific hardware action.
And when we build it up this way, starting from the physical reality of the wire and moving up to the logical rules in the software, the whole system suddenly becomes, well, clear. It makes sense.
You see, the reason subnetting feels so hard is because it is almost always taught completely backward. They start with the abstract math, but that's not how networks work. Real networks start with physical movement on a wire. Your gut feeling that it should be simpler than they were making it? You were right. The explanations were the problem, not you.
So let's just lay it all out one last time. The wire is the medium. The MAC address is your identity, who you are. The IP address is your location, where you are. The subnet mask is just the neighborhood rule, and your OS is the decider that uses that rule. It's really that simple. Each piece has one single, clear job to do. So why does getting this right matter so much? Because now you actually understand what a gateway is for. It's the door out of your neighborhood. You see why it's so efficient to keep traffic local whenever possible. You can finally grasp how the entire internet can scale by just connecting millions of these little neighborhoods together. And most importantly, you've separated those two fundamental concepts, identity versus location.
The goal was never to become a human calculator. The real goal is to see the system for what it is, a beautiful series of simple decisions that result in the physical movement of data across a wire. It's about seeing, not just memorizing rules.
And that kind of brings us to this final thought. What if networking isn't really about calculation at all? What if, at its core, it's simply about the art of drawing boundaries and then creating a clear set of rules for how to cross them? Thinking about it that way, well, that can make all the difference.